in this lecture, we will discuss about the basics of differential equation. First, the definition of differential equation. A differential equation is an equation involving an unknown function and its derivatives. Such equation is containing the derivatives of one or more dependent variables with respect to one or more independent variables. Following are the differential equations involving the function y. In the first example, you can see y has one time derivative with respect to x. In the second example, you can see y has two time derivatives with respect to x. And in the third case, we have y has maximum 3 time derivative with respect to x. And in the fourth example, you can see y has 2 time derivative with respect to t, along with the 2 time derivative with respect to x. We can classify the differential equations by their types. For example, a differential equation is called an ordinary differential equation if the unknown function depends on only one independent variable. For example, you can look at these three differential equations where the unknown function y depending on only one independent variable, and that is x. But if the unknown function depends on two or more independent variables, in that case, differential equation is called a partial differential equation. And here is an example where y being unknown function depending on two variables, t and x. The order of the differential equation is the order of the highest derivative appeared in the equation. For example, if you look at this differential equation, here the highest derivative is 1. So order of this differential equation is 1, and we call this differential equation is a first order differential equation. If you look at this differential equation where the highest derivative is 2, so this is second order differential equation. And this is third order differential equation because the highest order appeared in this equation is 3. And if you look at this differential equations, here the highest order appeared in the differential equation is 2. In the first term, you can see the second order derivative of y with respect to t, and in the second order derivative of y with respect to x. So this is second order differential equation. Degree of the differential equation is nothing but the power of the highest order derivative appeared in that equation. For example, if you look at this differential equation having one order differential, which is one order differential, first order differential equation. So, but the power of this first order derivative is 1, so degree is 1. And here is the second order differential equation where the power of this second order derivative of y with respect to x is 1, so degree is 1. And similar is the case for this differential equation where we have third order differential equation, but the power of this third order differential equation is 1, so degree is 1. But please remember that it is not possible every time that one can find the degree of any differential equation. Only the given function has to be polynomial function to define degree of the differential equation. In case the differential equation has log, exponential, and trigonometric function of the derivative, in that case, it is not possible to define its degree. For example, if you look at this differential equation, which is dy over dx is equal to tangent of x plus y, because here we have a trigonometric function of x plus y, so it doesn't matter. Important is that this trigonometric function shouldn't be a function of any derivative. So in this case, it is a well-defined differential equation having the degree 1 because it is first order derivative of y with respect to x having power 1, so degree is 1. But in this differential equation, having tangent of derivative of y with respect to x is equal to x plus y. Based on this definition, because tangent is a function of derivative of y with respect to x. So the degree of such differential equation is not defined. Now, if you look on this third example, having this exponential term, and this exponential term can be, though this exponential term can be expanded to bring it to a polynomial form, which is ex is equal to 1 plus x squared over 2 factorial plus x3 over 3 factorial plus so on. But when we include more terms in this series expansion, the second order derivative in this equation will vary each and every time. Hence, the degree of equation is not defined, but order is well defined, and that is 2. So in this case, we will say, because here the derivative is a function of exponential term, therefore degree is not defined, but order is well defined, and that is 2.